For our toy design project, we created the Food Globe, a 3D puzzle to teach children 3 learning objectives: energy transfer between organisms within ecosystems in the form of food chains, a basic understanding of the geography of the globe, and spatial problem-solving skills. We designed our toy to be safe and suitable for a 3rd grade classroom.
We wanted the toy to be fun while also hitting on multiple learning objectives. We also wanted to take something we remembered learning about in a boring way as a kid and teach it in a fun way.
To begin the process of actually making the toy part, we brainstormed different concepts that have to do with the environment. Generally, we started with more complicated ideas and then simplified them down based on our 2 main restrictions: cost and time.
After brainstorming and deciding on what our toy would look like, we did some research about food chains and learning objectives to figure out what images would go on our toy and what grade our toy would be suited for. We also interviewed a 3rd grade teacher to get some more input. Then we made 3D files in Autodesk Fusion and experimented with sizing and dimensions to find the best fit. We thought about different means and materials other than 3D printing, such as wood carving, but we decided it would be easiest to 3D print. Additionally, we utilized Photoshop to adjust the size and coloring of the globe image file we found so that it would better fit our puzzle.
We went through a good week or so of constantly having a 3D print going, and then met together with all of our materials to sand and glue the parts together. We also used a sealant once we glued the pictures on to meet the water-resistant requirement.
After testing with the children at a local elementary school, we found that most of the improvements needed to be made on the instructions we issued, not the toy itself. We adjusted the instructions to make them more kid-friendly and include more pictures. Other improvements were either outside of our budget or outside of our control, such as obtaining better magnets and printing the images at extremely high quality.
We faced several design challenges throughout the creation of our product. The actual 3D printing was the biggest one, because we discovered each part of the puzzle had to be printed in multiple pieces due to the design. Our first design was too big and took too long to print, so we had to make it smaller. We also couldn't get the dimensions to work perfectly on the new design, so we settled for sanding that part of the piece down. We also discovered that sanding is an essential step in gluing the plastic together, as the superglue did not adhere well on rough surfaces. A final mishap occurred when we misplanned and accidentally glued a couple of the pictures on the wrong pieces, but with some simple peeling and reprinting, everything turned out fine.
If we could redo the project, we would probably use a higher quality printer to print the images on our globe and use stronger magnets, as recommended by the children, as well as coordinate our printing more so we don't end up printing more pieces than needed again. It would also be good if we could use a plastic that is more lightweight, so that the magnets would work better.
Some tips for next year's freshmen are to go to the earliest makerspace orientation you can, meet with your group early and often, which worked really well for us, and really think long and hard about how you're going to make your design before you start doing anything.
We did not place it Fed Day, but we are proud of the product we produced and think that the Food Globe would be a great addition to any 3rd grade classroom.